Using a official school roster of 200 students and pick every 20th name. Systematic. I'm not spelling that right. Well, we'll just go with that. All right. Separating students by class, freshman, sophomore, junior, senior. Picking a simple random sample of size 25 from each of the 4 groups and then combining them to be your sample size of 100. Stratified. You took some from all the groups, right? Yes.
I have a question. Can't a lot of them be simple as well as stratified, for example, and that would make it more fun?
Using a random table, 100 names are chosen from the list of 200 students registered at the school. That's our SRS. Simple random sample. It's using a random number table. They started somewhere, like randomly picked a number, and then they took the 100 students after that, or something like that. So they had them all kind of listed out by name or something on a table. Separate the students by homeroom. Assign each homeroom has 25 students. Pick a random sample of 4 homerooms. If a homeroom is selected, all the students in the homeroom are included in the sample. Cluster. Look at that first one. And you're asking 500 of them, and you get 23% the response. What do we think? What's the biggest source of bias? Non-response. Because you didn't even get half of them, right? There's also could be a response bias in there, because if they do respond, were they honest? But the largest is that they just didn't respond at all. How about if you're asking those schools and you're asking your students about drugs? What do we think? Response bias is going to be the largest. Because my guess is if you're in high school, you're going to answer the question. I don't know how many high schoolers, I don't know any high schoolers that would tell their teacher what kind of drugs they use. I don't know any college kids that would tell their teachers what kind of drugs they would use if they asked. So the largest source is going to be a response. They'll probably have to respond, but they're going to probably be response bias. All right, how about the poll? You send out your questionnaires to 1,023 and you receive 15 of them back. What? Non-response? Could also be under coverage, because you're talking about, are we talking about all households, right? And you only chose 1,000, which is kind of small. So you got some under coverage happening there as well. Why do we think that response was so small? Yes. Right? If they asking about a foreign language, what are the odds you sent them the survey in the language that they actually speak? So you could have a lot of people that just couldn't answer. So maybe you need to look into your sampling method for that one. That would be my guess. All right, and then for the last one, what do we want to know about? Oh, asking if we think we should lower the drinking age. And you go to college campuses. And I would probably say the largest source would be undercoverage, right? You didn't get anybody, well, maybe you got a few, but you probably didn't get a large population above, say, 30, right? You probably got a lot of 30 and below people. And if I go to a college campus, they're probably going to tell me what? Yes, for sure lower that. You go out into the business world and you talk to people who are in their 50s and 60s, they're probably going to say, no, maybe we should raise it, right? So undercoverage would be the largest, but there's also, like you said, a response bias. Go through this. We want to divide our 100 plants into 2 groups, shade plants and sun plants. Within each group, you randomly assign plants to one of 3 types of music, classical, rock, or hip-hop. The selected type of music is played to each plant for 30 minutes a day over a period of 6 weeks. What type of experimental design is being employed here? I heard block. Do we all agree? Yeah. All right. So what does that kind of look like? Well, we've got our plants. What are they blocking by? Sun or shade, right? After they decide whether they get sun or shade, they apply the treatment. What's the treatment? Music. So after they decide whether they are a sun or a shade plant, they either get rock, or they get hip hop, or they get classical. And that happens in both of them. But first they had to be blocked into that shade or that sun first, in those two things. How are they going to know if it actually works or not? They don't have any plants that are in the shade and sun that aren't having music played to them. So what are they going to compare to? Probably the hundreds of other plants that have been grown without music, right? So they're not going to recollect data on something they probably already have. So sometimes we might not necessarily see what they are going to compare to, but that's because we already know that most plants are grown without music being played to them. So they're not particularly worried about that. The consumer group decides to test the effectiveness of a new organic laundry detergent. They initially get grass stains on a sample of 60 white t-shirts in order to see how well the detergent will clean them. Each shirt is randomly assigned to one of 3 water temperatures, cold, warm, or hot, and one of 2 wash cycles, regular or delicate. The level of cleanness for each shirt is recorded on a scale from 1 to 10. The sample the person evaluating the cleanness level is unaware of the treatment used on the shirt. The average cleaning level for each treatment group is calculated. All right, so I want to identify the response. So the response variable is kind of our thing at the end. What do we think would be the response that we're looking for? The clean level. What are we exploring in order to see what the cleanness level is? What are some explanatory variables? The wash cycles and the water temperature. What are the number of treatments that we actually have? 60? Well, we have 60 t-shirts, but those 60 t-shirts are gonna get put into a treatment, and what are the treatments that are being applied? 2 wash cycles and 3 water temperatures. So with those 2 wash cycles, any one of those temperatures could be chosen. So for the regular, you can have cold, warm, or hot. So that's how many treatments right there? 3. For the delicate, you can have cold, warm, or hot. So how many treatments is that? 3. So how many total treatments do we have? 6. So put together, we're going to have a total of 6 different treatments. What's the experimental unit? The 60 white t-shirts. The average cleaning level that was recorded, would it be a statistic or a parameter? Statistic, because it's based on a sample of 60 white t-shirts. Can't be the whole population because I don't think they could collect all the white t-shirts in the world and put grass stains on them. And then they said the person evaluating the cleanness level was unaware of it. Why was blinding used in this study?
Some people don't like, just the movement toward organic products.
That's true. So they are eliminating the bias. So the bias could be the fact that we're testing an organic detergent. The other bias is, I don't know about you guys, but I was taught that hot water is going to get my clothes cleaner. Right? So if I knew that a shirt was washed in hot water, that could affect my results or what I say about it. So even something as simple as that can impose some sort of bias. So they're trying to eliminate as much as possible through that particular avenue.